Hello everyone, this is Ji Zhao from UCLA. Today I'm going to talk about work, gender bias in contextualized word embeddings. Word embedding has already become a fundamental technique in NLP. It maps words with similar semantics to close positions in the embedding space. So the surrounding words could provide us a way to analyze the properties of the target words. For example, we can analyze the occupations for different genders using embeddings. And here is the result. A larger font size here means a closer distance to the target word. We see that in the neighbors of he, the answer includes businessman, mechanic, and engineer, while for she, it is receptionist, babysitter, and a nurse. Such biases in the embeddings can lead to discriminations in the downstream tasks, such as in coreference resolution. Coreference resolution is an important task in NLP. The goal is to extract all the phrases referring to the same entity in the given text. For example, the first sentence here, the president and his refer to the same person. However, if we change the pronoun from his to her, the correct link will break. And similarly, the model fails to correlate females with certain occupations, such as lawyer, programmer, and leader. Our work is inspired by the above observations. Even though many work have been done to analyze the bias in word embeddings, there are few talking about bias in contextualized word embeddings. Contextualized word embeddings have shown great performance improvement in many NLP applications. It will definitely become another important tool in NLP area. In this work, we are interested in understanding the bias in contextualized word embeddings, and we want to know if such bias will influence the downstream tasks. To be specific, we will use AMO in English as a case study in this work. In the first section of this work, I will talk about that AMO is sensitive to gender. Its training corpus is biased, and the AMO embedding we get will treat different gender unequally. And the bias in AMO will also propagate to the downstream tasks. Before we start it, let's first look at AMO. Traditional word embeddings will assign a fixed vector to a word even when the meaning is different. But for AMO, it will make use of a pre-trained language model. And when assigning the embedding to a word, it will take the corresponding context into consideration. For example, the two plays here will have different embeddings using AMO. Such context makes AMO contains richer information, which in return enhances many downstream tasks, such as question answering and coreference resolution. Next, I will start talking about the bias in AMO. We know that under most cases, the dataset we collected is imbalanced, and the same situation exists for AMO. In general, the corpus is biased towards men. We see that male pronouns occurs more frequently than female pronouns. As we are interested in gender bias, one way is to look at how people are mentioned in the sentences. So we also count the co-occurrence of male and female pronouns with occupation words, like lawyer and nurse. And again, it shows bias towards men, no matter what the gender inclination of the occupation word. Now we have shown that the training corpus for AMO is biased. Next, we want to know if such corpus bias will affect the AMO embeddings we get. To do this, we will first look at the gender geometry in the AMO embeddings. To visualize the gender geometry, we will use sentence pairs. For each pair of the sentence, the only difference is the gender-related words. For example, the two sentences here, the only difference is he and she. We will extract the AMO embedding for the occupation word in the sentence. and calculate the difference between the embeddings. We use it as the gender direction in AML. Now here is the result after we do the PCA on the gender direction we get. We found that in the gender space, the first two components explain more variance than the others. To better understand the gender geometry in AML, we map the AML embeddings of those occupation words to the two principal components we get. The orange dots here mean the sentence contains a female word, which we will call a female context, and the blue one means the sentence is from male context. We see that the first component's x-axis here will separate different contexts, while the second components will group words related to different genders. For example, male-biased words like developer and driver will lie on the top of the figure. So in this part, we see that AML can embed gender information into its embeddings. Next, we will show AML represent different gender unequally. We build a classifier to predict the context gender based on the occupation AML embeddings. We will treat the occupation as the mention to the entity, and its gender is obtained by the pronoun. So given one sentence, we will extract the AML embedding for the occupation word and to predict if there is a male or female word in the sentence. We found that the accuracy of the classifier is far higher than 50%, also indicating that the gender information in AML can propagate from the pronoun to other words. But for different genders, the classifier is 14 more accurately when predicting for the male context, demonstrating the different treatment for different genders. So by far, we show that AML embedding have gender bias. Next, we want to understand the influence of such bias on downstream tasks. We still use coreference resolution as the example. To evaluate the bias in coref, we will use the Venn bias dataset we built last year. So each sentence in the dataset contains two occupation words and one gendered pronoun. The two occupation words will have different inclination to male and female. The dataset contains two subsets. One is called pro-stereotypical, and the other is anti-stereotypical. The difference is whether the correct link in the sentence will follow the society bias or not. So the society bias can be obtained by the labor statistics. For example, the first sentence here had a link between the physician and he, which is the pro-stereotypical one, and the following one is an anti-stereotypical sentence. If one system does not have any gender bias, the performance on these two subsets should have similar performance. So we use the performance difference between the pro-stereotypical and anti-stereotypical datasets as a metric to evaluate bias in the coref system. And here is the result when we use AML embedding in the coref system. We see that with AML, we can improve the system's performance on benchmark dataset. However, the bias is also enlarged. So by far, we show that the bias in AML will also influence the downstream tasks. Next, we will propose different ways to mitigate such bias. In the following, I will talk about mitigation methods. I first talk about the gender swapping technique, which is the foundation of our methods. In the end, I will discuss the two methods we proposed. So first, let's look at gender swapping. This technique is proposed from our paper last year. The goal is to generate a gender-swapped variant for the input sentence. What we do is, given one sentence, we keep all the context the same, but change the gender words in the sentence to the opposite gender version. And with this method, we can keep all the correct link the same, but get a swapped instance. Both of our methods are based on this technique. And next, I will talk about the mitigation method. The first method is called data augmentation. What we do is, for the training dataset, we will generate its gender-swapped variance. We then union the swapped variance with the original training corpus and retrain the whole model on the union dataset. We see that with data augmentation, we can almost mitigate all the bias shown in the window bias dataset. So we see that this method is effective, but what if we don't want to retrain the model? So the second method we propose is to neutralizing the MO embedding for test dataset. What we do is, for each sentence in the test set, we first use the gender swapping technique to get the swapped instance, and then average the MO embedding for these two sentences and use it as the representation for the input sentence. With this live-weight method, we don't need to retrain anything, and we see that we can still reduce the bias to some extent without hurting the performance. To conclude, in this work, we show that MO is sensitive to gender, partly because the training corpus is biased, and the MO embedding we get will treat different gender unequally, and the bias in MO can propagate to downstream tasks. We also propose two methods to mitigate the bias. One is data augmentation, and the other is neutralizing the test MO. We see that data augmentation works pretty well with the contextualized word embeddings. But if we don't have access to the training corpus, neutralizing the test MO could also help to mitigate some of the bias. That's all. Thank you.